Welcome back to Enzyme Kinetics, Parameters of Enzyme Activity. This time, we will discuss the meaning and significance of the catalytic constants. To get the most out of the videos, I recommend watching them in order. This is a reminder that this presentation is Dr. Johnson's intellectual property. The Michaelis constant, Km, reflects the steady-state ratio of the ES complex to free enzyme. Recall that this is not an equilibrium ratio. Km is reported in units of concentration. If K2 is much smaller than K-1, Km is approximately the same as Ks and is a dissociation constant for the ES complex, giving us information about the affinity the enzyme has for the substrate. If K2 is not much smaller than K-1, then Km is a kinetic constant. There are a range of Km values. Small values indicate a high affinity for the substrate, suggesting that the ES concentration is greater than the free enzyme concentration for the duration of a reaction assay. The overall effect is a faster reaction rate. Large values indicate a poor affinity or poor binding, suggesting the substrate is poor. It is interesting to note that for many enzymes, the Km value is close to the physiological concentration of their substrates. In practice, we might use Km values to compare the same enzyme from different organisms or tissues, or different enzymes that catalyze the same reactions, or different substrates for one enzyme. The catalytic constant kcat is the first order rate constant for the conversion of the ES complex to the EP complex, where all the binding and release steps are fast. Therefore, kcat describes the rate determining step of the reaction. This constant is reported in units of inverse time and therefore gives us the number of reactions that a catalytic site can process in this unit of time. This is known as the turnover number. As you can see from the examples in this table, there are a wide range of kcat values from very fast to rather slow. The ratio of kcat upon Km is known as the specificity constant. It is a measure of the catalytic efficiency of an enzyme and is the apparent second-order rate constant for the reaction. This constant gives us a lower limit on the rate of formation of the ES complex, since kcat upon Km cannot be faster than the slowest step of the reaction. Association to form the ES complex is usually faster than conversion of the ES complex to EP. This constant is a measure of the specificity for competing substrates. As you can see in this table, there is a wide range of kcat over Km values. A good ES complex for an efficient reaction should have a small Km indicating fast and tight binding and a large kcat for a fast reaction. This means that the resulting kcat upon Km value will be very large. How fast can kcat upon Km get? It turns out that there is a limit, about 10 to the 9 molar to the -1 seconds to the -1. This is about as fast as substances can diffuse in water. Enzymes with kcat upon Km values near the diffusion-controlled limit are considered to be catalytically perfect. They catalyze a reaction each time it encounters a substrate molecule. These enzymes may even have a K2 that is faster than K1. Many biological chemists are fascinated by these super-fast enzymes and study them to figure out what makes them so catalytically efficient. All kinds of interesting things have been found out about catalysis from these studies. There are some additional terms that you may encounter for enzyme activity. A unit of activity is the amount of enzyme causing the transformation of a specific number of moles of substrate per unit time at 25 degrees Celsius and optimal conditions of pH, and so on. The number of moles is often 1 micromole and the unit of time 1 minute. However, these can vary. It's best to check the standards for each enzyme. Units of activity can be useful if you want to use enough of the enzyme to get the reaction you need to do done within a reasonable amount of time. For example, restriction digestion enzymes are usually sold in units of activity. The specific activity of an enzyme is the number of units of activity per milligram of total protein. If you are purifying an enzyme, it is useful to track specific activity to determine if you are purifying the enzyme or if you have been unfortunate and lost the activity. Next time, we'll look at the kinetics of reactions with more than one substrate.